Hello, in this video, we're going to be talking about how to write equilibrium constant expressions. For example, you're given this equation. And you're asked to write the equilibrium constant expression for this reaction. What you do is start by writing the equilibrium constant, which is Kc. And this is going to be equals to, we have the concentration of the product all over the concentration of the reactant. Now, if you have any coefficients, for example, if we have a coefficient here 2, and we have something here, maybe 3, that goes on to the exponent. So it stays on top here, okay? So for this particular equation, what we're going to have would be, this is your product and this is your reactant. So you're going to have the concentration of C, and 3 here becomes the exponent. And this is going to multiply the concentration of D, and there's no coefficient in front of D. You just have 1, and we don't bother to write 1. These brackets represent concentration of C, concentration of D. And then you divide this by the concentration of A, which is one of the reactants, and A has a coefficient of 2, and that becomes the exponent, and you multiply that by B. So this here would be your equilibrium constant expression. Now, what if we have a real equation? So let's say we have hydrogen reacting with iodine to give us Hi, and to balance this, we have 2 here. Now, to write the equilibrium constant expression for this, what we are going to have would be Kc equals the concentration of Hi raised to power 2, divide that by H2 times iodine. So this here will be the equilibrium constant expression for this. Okay. Now, there is something that I didn't mention at the beginning. Now, there are cases whereby you're given, so let's assume we are dealing with this now. Okay. Now, in this scenario, you can see that we have the states of these equations written. What is the importance of these states? We do not include liquids, solids into our equilibrium constant expressions. If you have liquids and solids, you will not include them. Okay, so in this case, we have gas, so all the gases will be included. And if you have aqueous solution, that would also go into your equilibrium expression. So for this one, the Kc would be equals to NH3 then squared all over nitrogen concentration and hydrogen, and that's you're going to cube. Okay, so this will be your equilibrium constant expression. Now, what if we have HCl plus sodium hydroxide, and we say this is an equilibrium? This is aqueous, and here we form sodium chloride, which is aqueous, and then we have H2O in liquid form. When writing the equilibrium constant expression for this, you're going to have to just start with just this. We're going to exclude this one, and that is because this is in liquid form. And like I said earlier, you don't add the liquid forms, okay? So this becomes sodium chloride all over HCl over sodium hydroxide. And if you note, you could see that this equation is already balanced. So and there is no coefficient in front of any of them. So that is why we don't have any exponents on any of those concentrations. So this is how you write equilibrium constant expressions, and I will try to do a video on how to apply these expressions in solving some of the calculations, review questions, and problems.